Welcome everybody to our video series on computer programming for mathematics. I, as always, am Dr. Lathram, and today we will talk about data types in Python's lists, tuples, and dictionaries. So now let's review some of our Python data types. So we really have two kind of major categories of data types. We have numerical data types and we have sequential data types. Under the numerical data types, we have integers, long integers, floating point numbers, and even complex numbers. In a previous video, we've talked about integers, long integers, and floating point numbers. And so if you want to kind of review that, head over and check out that video. Under the sequential data types, we have strings, lists, tuples, and dictionaries. So to kind of review a topic from mathematics when we're talking about sequential data types, remember that we have, or you're probably familiar with the idea of a sequence of numbers. And so probably you've seen before the Fibonacci sequence, which is just going to be 1, 1, 2, 3, 5, 8. Remember that for the next term in the sequence, you're just adding together the two previous terms that came before it. And we're able to index those as just being f sub 0, so f being the name of the sequence. F sub 0, the first 0th element in the sequence is just 1. F sub 1, so the 1 element in the sequence, the second element in the sequence. F sub 2, F sub 3 is 3, and so on and so on. Now, what we've really done there is to define a function f from the set 0, 1, 2, 3, 4, so our positive integers, and 0, and the range of those values is going to be the integers. And just kind of reviewing our function notation, f of 0 is going to be 1, f of 1 is 1, f of 2 is 2, and so on and so on and so on. And so when we define a sequence in mathematics, we're really just talking about a function from the set of either positive integers or the set of positive integers, including 0, and into some range of numbers that we are interested in. Now, the sequential data type is pretty much just the embodiment of that same notion of a mathematical sequence. That our notation that shows up that we're going to be using in Python is even really similar to the function notation that we're used to over in mathematics. So in math, we would write f and then the open parentheses and then the domain value that's going to go in there, and then we close the parentheses. In Python, instead of using the open parentheses, we're just going to use the close parentheses. So same exact idea, f being the name of the sequence, so the name of the object that we're dealing with, and n being the domain value, so the input value, the index value of a particular element in that sequence. Now, when it comes down to our data types, for our lists and tuples, we've got a domain, again, of the positive integers starting at and including 0. Now, the range of that can be any object which we can be defined in a program. And so we'll see kind of how that goes. We can index pretty much any type of programming object that we can possibly imagine and define. Strings still have the same domain value, so it's the positive integers and 0, but the range value is only going to be the set of characters that we have. Dictionaries are slightly different than that in that our domain now is just a list. So our domain is any list that we can define, and the elements of that list are really called keys. So the domain value is a list of keys. And again, what can be the range value? Well, the range value can be any object that we wish to define in our program. So now let's fire up idle and take a look at some of the sequential type objects as we're kind of dealing with them on a rubber meets the road kind of basis. And so how we actually define lists, tuples, and dictionaries will really kind of be determined, we'll know by the kind of brackets that we use to define them. So for example, if we wish to define a list, so a list, we will use square brackets. And so if I want to have, let's begin with a list of 3 elements. Say I'll put a character in there, I'll put a floating point number in there, and let's put an integer in there. So we've got 3 different data types actually contained in that list. So that's going to be a dictionary. For a tuple, the kinds of brackets that we'll use will be open brackets. So they really look like our ordered pairs from over in our mathematical setting. So if I do the same thing, and so now instead of using square brackets, I use the open brackets. I can do the same thing. I can have the same types of objects. I can have A, I can have 2.1, I can have 3, but now I'm going to use the open brackets to do that. And to see what kind of type of object I'm dealing with here, I can always do what type is X. Well, X is a list. Well, what about Y? Y is also a tuple. Okay, so I've used 2 different types of brackets, square brackets for the lists, round brackets or open brackets for the tuples. Now if I want to do a dictionary, so dictionaries have set brackets. So set brackets, I've got this curly bracket, and now dictionaries are a little bit different in that my domain values are not the 0, 1, 2, 3, and so on, positive integers and 0 anymore. My domain values are keys, so they're lists on their own. And so I'm really free to make those things anything that I want them to be. And the notation that I use to represent a dictionary element, I will list the key first. And so let's say that my key is my character. I'm going to give it a key. It's a string. So my key is going to be character, and then I represent the value that that character is going to take. I put a colon, and then I put the value that I want the character to have, and I want it to have a value of A. Then I can have a float, and I want my float to have a value of 2.1, and then I can have my integer. My integer is going to be 3. And then I close my bracket. And the type of object that I have here is a dictionary. Okay, now all of the keys that I actually have for the dictionary, the keys are the string character, the string float, and the string integer. And so if I want to refer to those things, those are the keys that I have to have, that those are going to be my domain values that I will put into. And so now let's take a look at how I can actually refer to particular items in my list or tuple or dictionary. So for the the syntax is pretty much the same for all of it. Remember, it's very similar to our function notation, except instead of using the open brackets for the function notation, we use the square brackets. And so if I wanted to start at the 0th element, so of my list or my tuple, I would just say, all right, well, x0, what element is that going to be? Hit return, and it's going to return me the character A. If I look at the first element, that's 2.1. And if I look at the second element, then that's going to give me a value of 3. Now those 3 are all different types, and if I actually say, well, what type of object is x0, it's a string. What type of object is x1, it's a float. And what type of object is x2, it's an integer. And so I can have different different data types in a particular list, but the list itself is its own kind of data type. That same kind of thing is also going to hold true for the tuples. So if I wanted the 0th element, that's going to be A. The first element, 2.1, and the second element, 3. And those all, again, retain their own data type. And if I look at the data type for the second element, that's going to be my integer again. And so the tuples and the list in that respect are really very much the same. So you can say, well, why exactly do we have, if they're pretty much the same, then why do we have 2 different things? Why can't we just have lists, or why can't we just have tuples? And the answer for that is something called immutability. Lists are not immutable. Tuples are immutable. Immutability really just being, can the elements be changed? So, for instance, if I didn't want to have a value of 3 as my integer value anymore, then in my list I could just say, well, x3, that's going to be, or x2, that's the third element in there because I'm starting at 0, so 0, 1, 2. My second element in there, I don't want it to be 3, I want it to be 5. And so if I type x, now my third element has been changed to 5. So the 3 is not there anymore, now that 3 has been changed to a 5. If I try to do that same thing with the tuple, watch what happens. Well, I want y2, which has a value of 3. Let's say that I want y2 to be that value of 5. Oh, no. And what I'm seeing here, type error tuple object does not support item assignment. That's kind of another way of saying tuples are immutable. You can't just change a particular entry in a tuple. Once you set it, it is set. And so if you want to have a different value in the tuple, then you have to construct a brand new tuple that has that value in there. So you either have to copy it and then change the value during the copy, or you are making a brand new one from scratch, something, but you are not allowed to change the original tuple all on its own. So that's why we have 2 different things. So referring to elements, lists and tuples are exactly the same. They are different in that lists, I can change the items in a list. I cannot change the items in a tuple. Dictionaries, if I wish to refer to a particular value in a dictionary, the format's kind of the same. But now, instead of typing in 0 or 1 or 2, now I have to use the keys that I actually use to refer to the items. So if I wanted the character in the dictionary, well, I type z of character. So I give it the string that I had as the value. So z of character is going to be A. What about z of the float number? that's in there, well, that float number is 2.1, and z of the integer is going to be 3. Now here I used strings as the keys. I wouldn't have to use strings as the keys. I could use numbers as the keys. If I wanted to do that, that would be perfectly fine. That kind of how the dictionaries are slightly different. They're not necessarily stored in that sequential order. They're stored by the keys, which if I'm just listing through there, that may or may not be the order in which I put them in. And so dictionaries kind of give me a different way of indexing my items if I don't want to use the positive integers in 0 anymore. And so this is kind of giving you a little bit of an introduction to how we can write lists and tuples and dictionaries, and kind of how we refer to particular elements. Oh, what if you wanted to are dictionaries immutable or mutable? Well, let's find out. If I say that I want the integer, now instead of having it be 3 like it was just now, if I make it 5, will Python allow me to do it? Yes, it will. No error. So our dictionaries are not immutable, so they are mutable objects as well. So they can be changed, the entries can be changed in those, and they aren't fixed. And so if I type z, now it lists all of my integers, my floats, my characters. Now notice that whenever it prints that out, when I was saying that they're not necessarily stored in the order in which I necessarily put them in, that is true here. Notice what we've got. I've got an integer, a float, and a character. That's not how I put them in. How did I put it in when I defined it? I put the character first, and then I put the float, and then I put the integer. So there's not really a particular ordering in the dictionaries themselves. It's just you give it the key, it's going to return you the value. And so as it's stored, we don't necessarily have a particular order associated with it. And so this has kind of been a little bit of an introduction to the lists, the tuples, and the dictionaries, and how we go about defining those. So I hope this has been kind of useful to you. Leave your comments down below, and I will see you guys next time.